Hi students, this is Viswanath, chemistry faculty for NEET and IIT exams. In last class we completed deviation of real gas from ideal behavior and Boyle's temperature and compressibility factor. Now see the numericals related to compressibility factor. The compressibility factor of a gas is more than unity at STP. Its value of Vm means molar volume. So compressibility factor is greater than unity. Greater than unity means it shows positive deviation. It is related to real gas. The given compressibility factor is related to real gas. Say this, for ideal gas Z equal to 1. That means for ideal gas molar volume is 22.4 liters or 22.4 decimeter cube. But given Z greater than 1, so it is related to real gas. So molar volume is also greater than 22.4 liters. We know the expression for Z. Z equal to PV by nRT. Volume is more than this value. Then only Z value is greater than 1. So here Vm is greater than 22.4 liters or 22.4 decimeter cube. What is the option? Option A is the answer. Next, a real gas expected to exhibit maximum deviation from ideal gas law at under what condition a real gas exhibit maximum deviation? That is the question. So in ideal gas intermolecular attractions are negligible. Under what condition we can observe this type of situation means at very low pressure and high temperature intermolecular attractions are negligible. But coming to real gas, intermolecular attractions are considerable. So intermolecular interactions are present between the gas molecules in case of real gas. That's why real gas exhibit deviation from ideal behavior. These molecular interactions we can observe more under high pressure and low temperature. So high pressure and low temperature are the conditions for real gas to exhibit maximum deviation. Then what is the option? High pressure and low temperature. Option C is the answer. Next, compressibility factor Z for N2 at minus 50 degrees Celsius and 800 atmosphere pressure is 1.95. Calculate the mole of N2 gas required to fill a gas cylinder of 100 liters capacity under the given conditions. So number of moles of nitrogen gas we should find out. First write down given values. Z equal to 1.5 and temperature equal to minus 50 degrees Celsius in Kelvin scale 223 Kelvin, pressure 800 atmosphere, volume 100 liters, universal gas constant 0.0821 liter atmosphere mole inverse Kelvin inverse. Then Z equal to PV by nRT. We want number of moles. So N equal to PV by ZRT. Substitute pressure, volume, Z, R and T. Then we can get number of moles. That is 2240.8 number of moles of nitrogen is present under these conditions. Next, the compressibility factor for a given real gas is 0.927 at 273 Kelvin and 100 atmosphere. Calculate the amount of gas required to fill a gas cylinder of 100 liters capacity under given conditions. Molecular weight of gas equal to 30. In this question we have to calculate amount of the gas. Say this, for real gas PV equal to Z into nRT. PV equal to Z into N means number of moles. What is the formula for number of moles? Weight by molecular weight into RT. Note down the given data. Given Z value 0.927, temperature 273 Kelvin, volume 100 liters, pressure 100 atmosphere. Substitute all these things. We should calculate weight of the gas. So W equal to molar mass M into PV divided by Z into RT. Substitute all the values. Then we can get weight of N2. W equal to 14.443 grams. 14,443 grams. In terms of kilograms, 14.44 kilograms. Next, calculate the compressibility factor for CO2 if 1 mole of it occupies 0.4 liters at 300 Kelvin and 40 atmosphere. Comment on the result. Okay, so Z value we should calculate. Note down given data. Given volume V equal to 0.4 liters, temperature 300 Kelvin, pressure 40 atmosphere, number of moles 1. Now Z equal to PV by nRT. Substitute pressure, volume, number of moles, R and temperature. We can get Z value 0.65. Now say this. 0.65 means it is less than 1. Since Z less than 1 and thus nRT greater than PV. Z less than 1 means denominator value is more. Then we can get this type of fractions. Fractions means decimal value. So here Z less than 1, it implies nRT greater than PV. In order to have Z equal to 1, volume of CO2 must have been more at the same pressure and temperature. If volume increases more than PV greater than nRT, then Z is equal to 1. Or CO2 is more compressible than ideal gas. Here nRT greater than PV means volume is less. Volume less means CO2. Inside the CO2 gas, between the molecules, attractive forces are there. That's why we can compress it easily than ideal gas. This is the indication. So here Z value less than 1 means volume is less. That means CO2 gas is more compressible than ideal gas. Next, 1 liter of a gas at 300 atmosphere and 473 Kelvin is compressed to a pressure of 600 atmosphere and 273 Kelvin. The compressibility factors found are 1.072 and 1.375 respectively at initial and final states. Calculate the final value. Okay. A gas compressed from one pressure and temperature to another pressure and another temperature. Z values are given. Initial volume is given. Final volume we should calculate. So note down given data. P1 equal to 300 atmosphere. Volume V1 equal to 1 liter. T1 equal to 473 Kelvin. Z equal to 1.072. P2 600 atmosphere. V2 we should calculate. Temperature T2 273 Kelvin. Z compressibility factor Z2 equal to 1.375. Now Z1, what is the formula? P1 V1 by N or T1. Z2 equal to P2 V2 divided by N or T2. In order to calculate final volume, we should divide Z2 by Z1, then related formula. So finally we can get V2 equal to Z2 by Z1 into T2 into P1 V1 by P2 T1. Substitute all the values, we can get volume in liters 0.3701. In milliliters, value is 370.1 milliliter. Next, see the next numerical. At 273 Kelvin temperature and 9 atmosphere pressure, the compressibility factor of a gas is 0.9. The volume of 1 millimoles of gas at this temperature and pressure. Here volume we should calculate. So note down given data. Pressure P equal to 9 atmosphere, temperature 273 Kelvin, Z value 0.9, number of moles equal to 1 millimole. So volume we want, then Z equal to PV by nRT, V equal to Z into nRT by P. So Z value. Here number of moles, first consider 1 mole into R value 0.0821 into 273 divided by 9. So V equal to 2.24 liter per mole. This volume is related to per mole. Now we want for 1 millimole. So 1 mole occupies 2.24 liters means 1 millimole occupies 2.24 milliliter. Yes. So therefore volume of 1 millimole of gas equal to 2.24 milliliter. Then what is the option? Option C is the answer. Next. The density of steam at 100 degrees Celsius and 10 power 5 Pascal pressure is 0.6 kilogram meter power minus 3. Calculate the compressibility factor of steam. Okay. Density is given, temperature, pressures are given. Z value we should find out. Z equal to PV by nRT. Density equal to mass by volume. That is W by V. So Z equal to PV divided by number of moles. Formula is weight by molar mass into RT. From this we can get molar mass into pressure into volume divided by weight of the steam into RT. So V by W, here D means W by V. Here we have V by W means 1 by D. Therefore Z equal to molar mass into pressure divided by density or T. Substitute all the values, we can get Z value. Next. Number of N2 molecules present in liter vessel at NTP when compressibility factor is 1.2. So volume is given. Temperature, pressure, NTP conditions. Compressibility factor is given 1.2. Number of molecules we should calculate. Say this. Z equal to PV by nRT. That implies N equal to PV by Z into RT. Number of moles first we calculated. And number of molecules we want. Then what is the formula? Number of N2 molecules equal to number of moles of N2 into Avogadro number. So number of moles 0.0371 into Avogadro number, that equal to 2.23 into 10 power 22 number of molecules. Okay students, practice well. We'll meet you in the next class.